So this one's going to be about making a quadratic equation in standard form into vertex form. Let me clear this out. This particular example I want to look at here, and that is going to be 2x squared minus 12x plus 22. Let's say this is your function. This could be y, or it could be fx or anything. So we have to change this in some sort of way to make it look like vertex form. Now, vertex form looks like this. Let's label everything. So vertex form, that is the one with the h's and k's. Y equals a, x minus h. Now, h is like the axis of symmetry. That is the x coordinate of the vertex, squared plus k. So your vertex here is h comma k. So we're going to try to make this look like this. Now, one way you could do this, you can kind of cheat and actually find a vertex from whatever you know how to do, like finding axis symmetry using like b over 2a. But the way you're really supposed to do it is by completing the square. So this is our goal here. We're going to make standard form look like vertex form. So one thing here, we're going to focus on this part. We want to take out the a, which is 2. So we're going to factor that out, get x squared minus 6x. Of course, we could also factor out an x, but that doesn't really help us in this case. Now here, this is actually your b value here. That's b. This is the thing where we half and square it. To be called completing the square requires this number here. So in this case, I don't like the fact that the 6 looks so much like a b, but okay, so 6 over 2 squared equals 9. This is the thing that we're going to be adding in. I have to be careful when we add this much. So we have 2 and then x squared minus 6x plus 9 plus 22. So I took this statement. Now, I'm not even working with like an equation right now, just like an expression. If I want this to be equivalent, I can't just add in that 9. I have to take it away as well. But I didn't really just add a 9. I added an 18. So to fix this, I have to subtract 18. So not to do too many steps in once here. So right now, I have this. And then subtract 18, so that affects this number. Okay, this is all to make sure everything's equivalent. Now, what's in the parentheses you can factor as x minus 3, x minus 3. It's always going to be the same factor. That's what it's designed to do. So we say x minus 3 quantity squared. And now you have it in vertex form. That's how we go from standard to vertex form. Let me see if I can come up with another example of that. Right, standard to vertex form. I shall make up a equation and see how it works. Say I had this. So as I said before, you can find your vertex using axis symmetry and all that stuff. But let's see if we can work with these to manipulate it algebraically. So I want the x squared by itself. So I'm going to factor out this -4. This is where it gets weird. -4 times what gives you 10x. So you basically can take 10 and divide it by -4 to figure this out. Okay, so that's going to be like -5 halves. This one's getting ugly already. Okay, so but this should work though. We got that portion and -6. So completing a square says I should take the b value and do half and square it. So completing the square is basically remembering to do this thing, b/2 squared. B is already halved here, so it's 5/2 halved is really 5/4. 5/4 squared is 25/16. So I'm going to add that in here. This is an unusual one. This is why I try to like pick them out of books. Okay, so what did I actually change here? I didn't just add a 25/16, I added a 25/16 times a -4. So 25/16 times a -4, using cross cancellation and all that stuff here, that comes out to -25/4. So I'm going to have to add that back in here to make it be the same. So this is going to be always half of b, which is going to be 5/4 here, squared, and whatever this comes out to be. Let's see, like 6 is 24/4. I think it's just 1/4. Right.